Alright all, Mr. Callen here to help you with today's lesson, Monday, May 5th. We're going to be talking about square roots, how to solve quadratic equations. So let's get to it. Alright, lesson 8.10, continuation, solving quadratics by taking the square root of both sides. You should, ladies and gents, have your worksheet with you and Desmos calculator ready to go. I'm going to leave the answers here, so if you'd like to check your work for week 16, go ahead and pause the video, come back when you're ready. Now for the back side, pause if you need, come back when you're ready. Goal today, again, to reiterate what we have already learned. We've already learned solving quadratic equations, only we've learned by splitting it up. We're going to focus today and a little more tomorrow solving by taking the square root of each side. A reminder, please, what this plus or minus means. It does mean a positive or a negative. And to review square roots, what number times itself will give you the number inside the radical symbol. For instance, the square root of 9 is 3. Square root of 49 is 7. The square root of 64 is 8. On the other hand, the square root of 60, ladies and gents, is what would be called an irrational number. It goes on forever and it does not repeat. Now, you may either leave it written in radical form as a square root of 60, or you may round. Mind you, this is only an estimate. So it really will depend on what the directions ask you to do. Again, we saw this on Friday. If you were not with us on Friday, you might have missed this. A few ways to solve the same equation. We started with Ahmed's way of splitting it up into two different possibilities using factoring. What two factors multiplied together to make 0 could lead us to find the solutions. In this case, we have two solutions, 7 and negative 5. Now, the Binta graphing way graphs both that red parabola to describe x minus 1 in parentheses squared. Furthermore, she then says, but I want to see what happens at 36, graphs the horizontal line. And our goal then would be to find the point where that red parabola meets the 36. Naturally, to no one's surprise, it will be right at negative 5. Whoops, that's not what I meant to do. Oh, it's not going to give me that negative 5 back. It'll meet right at negative 5. And then, of course, it will also meet when x is 7. Now, what we began talking about just last week, if there's another method, so method number 1 with factoring, method number 2 with graphing, method number 3, is there any other way to solve quadratic equations just using numbers, symbols, variables, and not a graph? Charlie reminds us that to get rid of a second power, we take a second root. A second power and a second root cancel out in much the same way add cancels out subtract, divide cancels out multiply, etc. But we do have to understand that when we take a square root, there might be two numbers that would give us 36. For instance, 6 times 6 gives us 36, but also we could have that inner value be negative 6. And in finishing that up then, if we were to add 1 to both sides, to no one's surprise, x could be positive 7, which is exactly what we saw with Ahmed's way and Binta's way. We could further add 1 to positive 6 and find, oh, that was the 7. Wake up, Mr. Callen, that could have been negative 5, right? The point is the answers are all the same, just different ways of finding it. Our focus today is going to be solving using the square roots of both sides. So go ahead, grab that worksheet, and let's get rolling. I'm going to go ahead and do some odd problems with you and then have you do the evens, checking back for your answers. Let's talk number 1. We're going to solve using square roots. So we have x to the second power is equal to 9. We'd like just to know what x is. And the inverse of a second power is a second root. Being fair to both sides keeps us balanced, but I do recall that when we take the square root of something, we could have a positive or a negative. Now, I often will cross off my inverse operations. Hey, look what's left. X equals, that is precisely what we wanted. And x could be a positive 3 or a negative 3. I'm going to get you used to writing it with the plus or minus symbol. However, for now, if you really want to write x equals 3 and x equals negative 3, then you may write it that way. As you can see, in mathematics, we like to be efficient. If you could just use a symbol to describe the fact that there are two solutions, go for it. Now, as we get into number 3, I want you to look at number 3 and number 1. How are they similar? How are they different? We still have a square power. We still want to get rid of a square power with a square root. And of course, be fair to both sides. Square power and square root cancel out, which leaves us with an x equaling, wait a second, what number multiplied by itself would give us negative 4? Well, something here doesn't make sense. For instance, if I had tried 2 times 2, 2 times itself certainly does not equal negative. Next up, some will point out, well, what if you try a negative? If you have negative 2 times negative 2, that also is not equal. Now, may I remind you, please, for those of you that are trying to fudge your way around it, this is not a square root. Square root is what number times itself. Negative 2 times positive 2 certainly equals negative 4, but that's not a square root. In fact, there's no such answer. There's no possibility. And when there is no possibility, we know what to write. We're going to write no solution for number 3. There will never be a number times itself that would give us a negative 4. Impossible. On to number 5, wait a second. What's up with number 5? Number 5 has an x squared just like number 1. It has a negative number on the right like number 3. Does that mean there's no solution? Well, let's dig in a little bit and find out. I would certainly like to get rid of that x squared, but first, we have a negative 2 times an x squared. So I'm going to get rid of the times. How do we undo multiplication? We're going to go ahead and, to eliminate multiplication, divide it in 2 parts, where naturally 2 divided by 2 and the opposite of a negative cancel out. That leaves us only with x squared equals, oh, check this out. The opposite of a negative ends up being a positive 4. So just when you were concerned that there was going to be no such answer, we'll take the square root of both sides now. Square root of a square power cancel out, leaving us with x equals, and there is 2 different answers that would give us 4. You see, multiply 2 times 2 and that'll give us 4, or a negative 2 times a negative 2. Again, if you really want to, you may write x equals 2, x equals negative 2. So there is a possible answer for number 5. If you don't believe me, you are always welcome to come to the side and check it. So say substitute in negative 2, why not? Negative 2 times negative 2 would be a positive 4. Desmos would take care of all this for you. The opposite of 2 4s is negative 8, which is a true statement. So we were able to find a solution with number 5, but not with number 3. Okay, I'm going to encourage you in a moment to pause the video, do numbers 2, 4, 6, come on back when you're ready to check your answers. Number 2 is going to be positive or negative 4. Number 4 would be positive or negative 5. But number 6, there is no possible number that would make this statement true. Onward we go to level 2. Let's see if you're ready for more difficult problems, where once again our goal is to find what x will equal, what value or values will make a true statement. Now, in this particular case, again, I notice if our goal is to get x by itself, surely we're going to get rid of that second power. We also need to get rid of a 2. Oh, and we get rid of negative 3. We got multiple steps here. Now, many of you recognize the fact that we will eliminate the constant term first. So let's go ahead and add 3 sides. So long as we do it to both sides of the equation, we keep it fair, balanced, and equivalent. Now that 2x squared equals 18, let's eliminate the multiply 2. 2 halves makes 1 whole set of x squared, that is. And 18 halves you could rewrite as 9. Will this have a solution? I do believe we can take the square root of both sides. Square power, square root canceling each other out, leaving us with x equals a positive or a negative. And what number times itself would give us 9? Well, 3 times 3 is 9, or negative 3 times negative 3. Final answer here, x is going to be positive or negative 3. Onward we go to number 9. Again, look at the problems. Look at how they're similar. Look at how they're different. They both have a quantity in front of an x squared. They both have a subtract to get rid of. So let's eliminate that negative 15 by adding 15. Being fair to both sides would keep them equivalent. 15 minus 15 cancels out, leaving us with 4 sets of x squared equaling 200. At this point, I'm going to undo or eliminate the multiply with divide. 4/4 gives me 1 whole set of x squared, and 200/4 is 50. Now eliminate that second power with the second root, being fair to both sides. And of course, a second power and a second root will cancel out. X equals a positive or a negative. Wait a second. The square root of 50, ladies and gents, is not a rational number. Square root of 49 is exactly 7. The square root of 64 is exactly 8. The square root of 50 is going to be 7 point some crazy, ugly, irrational. Because the directions do not ask us to round, it simply says solve, that means we are looking for an exact answer. So we must leave it in irrational with the radical form. Again, for those of you that really want to, you may write that x is equal to the positive square root of 50, or that x is equal to the opposite, or a negative square root of 50. And for those that were guessing about 7 1/10, you are awfully stinking close. Look at how those problems are similar. Look at how they're different. Then pause your video, go on to 8 and 10, come back when you're ready to check your answers. Number 8 is in fact a possible equation with 2 solutions, positive or negative 5. Number 10, however, is not. I like to put that negative 1 right here. See if you can figure out why there is no solution. If not, talk to a partner or ask a question when I return. On to level 3, and then if you are ahead, you can fast forward through this part of the video. Level 4 is the toughest of the tough with some challenges at the bottom. Again, we are asked to solve for x. Again, we have this second power up here. Now, I want to get rid of the 1, but the 1 is grouped. Everything is grouped together in parentheses. So I guess I can get rid of that second power. Now, the inverse of a second power, naturally, would be a second root. And provided that I take that second root from both sides, I keep it fair, I keep it balanced, I keep it equivalent. Second powers and second roots are inverse operations and would cancel, leaving me with x plus 1 is equal to a positive or a negative. Is the square root of 49 rational or irrational? Oh, that one's quite nice. Now, I'd like to say I'm done, but I don't want to know what x plus 1 is. I just want to know what x is. So I'm going to go ahead and eliminate a positive 1 by subtracting 1 from both sides. Where 1 and negative 1 make 0, that leaves me with only an x. Good, that's precisely what we wanted to solve for. And we could write this as negative 1 plus or minus 7. However, I would argue that it would be far better to actually compute these out. So x is going to equal negative 1 minus 7, or negative 8. Meanwhile, x could also equal negative 1 plus 7, or 6. Now, if you're wondering what is going on here, come on back to the original equation. Some number x, increase it by 1, then square that quantity, should equal 49. Now, if you were to go ahead and substitute in, well, let's start with 6. What's 6 plus 1? 7. True or false? 7 squared is 49. That's a true statement, isn't it? Meanwhile, don't be intimidated by the negative. Substitute in negative 8. Negative 8 plus 1 is negative 7. Now, negative 7 multiplied by itself, a negative times a negative, is equal to a positive 49, which again makes a true statement. So this one has 2 solutions, negative 8, 6. Because that square root was rational, we did not need to leave anything in radical form. As we go on to number 13, look at how they're similar, look at how they're different. I see 2 quantities, both in parentheses, both squared. So let's go ahead and say we're going to get rid of that square power. Inverse of a second power would be a second root. being fair to the other side. A second power and a second root would cancel out, leaving us with the sum of x and 4 equaling, wait a second. I mean, I'm not even going to get to that plus or minus piece, because I'm asking myself, what number ever multiplied by itself could give us a negative 64? That's impossible. So as soon as you see that, you can say, wait, you can't have a number multiplied by itself equal negative 64. Therefore, we're going to write the fact that what number makes this a true statement? No number makes it a true statement. There is no solution to number 13. Let's finish up with number 15, please. And you might be tempted to say, hey, Mr. Callan, look at this. Something times itself equals negative 18. This is going to be no solution, right? Well, we do have a product of two amounts, a negative 2 times the square of x minus 3. So I'm going to eliminate that multiply with divide. I'm going to divide both sides by negative 2, and perhaps you can already see where we're heading. The 2 divided by 2 makes one whole canceling out. Opposite of a negative cancels out. Leaves us with the difference of x and 3, taking the square. And the opposite of a negative turns into a positive 9. Folks, there is a way to multiply two quantities to make 9. So this should have a solution. Let's go ahead and take the second root of both sides, where a second power and a second root will cancel out, leaving me only with the difference of x and 3 equals a positive or a negative, rational or not rational. Well, we can take the square root of 9 to make it a lovely integer of 3. But I want to know what x is, so let's eliminate that plus 3. Excuse me, let's eliminate that minus 3 with plus 3. Thereby leaving a positive 3 and plus or minus 3. Now again, what does that mean? We have a 3 plus 3, and we have a 3 minus 3. So our final solutions, 3 subtract 3 would be 0, or 3 add 3 would be 6. If you don't believe it, go back up to the very first equation that we got. Substitute in 0. 0 minus 3 is negative 3. Negative 3 raised to the second power. Negative 3 times itself is positive 9. And negative 2 times positive 9 does in fact equal negative 18. Naturally, if you put in 6, 6 minus 3 is 3. 3 squared is still a positive 9. Negative 2 times 9 is still a negative 18, and that also is true. Go ahead and pause your video at this point. Head to numbers 12, 14, 16. Come on back when you're ready to check your solutions. Number 12, 7 and 5 would make the statement true. Number 14, you'd have a negative 10 and a positive 2. And 16, once again, we run into something that is impossible and cannot be done. At this point, if you'd like, you can pause the video. If you're ready to get on to 17 through 20, pause your video and come on back when you're ready to check solutions to these. Level 4 type problems, folks. Answers are right here. Number 20, if you have the negative 1 out in front, you'd end up with something times something equals a negative something, and that is just impossible. There, of course, are some challenge problems below. If you have any questions, check with your partners or see if you can check with me tomorrow. At this time, you should be asking for, or toward the end of the class, you'll get some exit problems from your guest teacher. And I would encourage you to head to page 986, Advantages and Disadvantages of Using This Radical Symbol. I mean, sometimes it's going to be a very nice number, and sometimes it would not be a very nice number. Plus or minus symbols are good ways of writing solutions that have two answers. And then you can also take a quick look at the summary down below because we were pretty rushed last week. Hey, sometimes we have some very nice solutions, x equals 7, x equals negative 5. Other times we'll end up with something that's crazy, ugly, irrational. Now we can still use the positive or negative symbol, and we can write exact using the radical symbol, or we can come up with an approximation to decimals. It all depends on what well, basically what the directions will ask for. All right, folks, that's what I got for you for today. Take care, do well, let's grow. I'll see you soon.